No, let's answer it. It's a fair question. Uh, so I mean, Japai is a very new concept. It is still under wraps. Jan LeCun has been speaking a lot about this. Now, if we look at where is the relevance of Japai and why the talks are even coming, this is more about how do we define artificial general intelligence. So, is human intelligence around language processing, or is it much more than that? That is where Japai is heading, and when we want to build systems which are physically aware, which are really able to take real-time decisions, the question is are LLMs enough, or do we need a new world architecture? I think things will move there, but I would say it's still early stage. The second thing that I want to tell audience here is while there are these talks of AGI and advancements, there is a lot that can be done with the existing advances itself. So I would highly encourage students to first learn the existing technologies possibly and see how you can put it to good use.
Namaste, my name is Neela, and we are also trying to bring closer the academia and industry. I was working for last 18 years in industry and as a machine learning architect till September 25, and now I'm working with the students in the real project-based learning. So a question with the, all of you probably, that how the people like we are working right now on a very small scale and how we can collaborate uh, for the job or for a job market like Aparna with the Tata Sons. Roma, you talked about lot of initiatives which Google is taking. And funny, when you are talking about that Telangana government is taking a lot of initiatives in skill upskilling. So a question with all three of you, how we can collaborate or how, uh, what are the ways where the industries of our scale can collaborate. Thank you.
So I'll give you a prime example of talking about collaboration with a small scale company which ICOM has already is institutionalizing within its ecosystem. It's a uh, without disclosing the numbers, suffice it to say it's a small company based out of Silicon Valley, but with really good technology, okay, that could be potentially disruptive. And we have partnered with them, a company called Blaze, and putting up a center of excellence in ICOM headquarters, right? And we are looking at, on the other end of the spectrum, we have partnered with Pearson, which is a $5 billion curriculum company, and we are partnering with the likes of Google and whatnot and all of that, right? So the whole philosophy that I'm creating and under the vision of Honorable Chief Minister Revant Reddy Garu and Honorable IT Minister Sridhar Babu Garu is to create an open platform where we can spread our tentacles to the rest of the ecosystem. That includes the industry, academia, and research. So I'm more than happy to take an offline conversation with you and connect you with the necessary people on my team to have a program in place with you.
Thank you. I'm just conscious of time. With this, we'll wrap this panel discussion for now, and we look forward to engaging with many of you offline. If you could just. We're also very grateful to all you speakers for making time to be here. We have a small memento which we would like to share with all of you. So we'll take a moment for that, please.
एक फीट आती रहती है।
Have the QR code up on the screen, please. But what we have learned, what we have actually seen, what we have made different students, startups, corporates to actually perform during our Green Mind Sustainable AI Hackathon, which happened from 31st October to 15th of November in Bangalore. And in my panel, we have Archana Joshi. She's an AI strategist currently working with Orient. We have Naresh Chaudhary, Senior Vice President in Infosys, who looks after not only the DevOps tools, but also the AI implementations throughout the organizations. Srinivas Varadarajan, not only he is a Senior Chief Architect of Aadhaar, but he has his own company called Vidya Labs, which is a completely green data center, where CPUs, GPUs, everything runs in around 100 plus kilowatts, not even near to a megawatt. Right? We have with us Dr. Gayatri. She is the principal of Sir M.D. School of Architecture, Design and Planning, where we have launched our Sustainable AI Center of Excellence. We have Vineet Mittal. He is the Senior Vice President of Zero Labs. Zero Labs created quite an amount of noise because they are the ones who work with IIT Madras and now working with various organizations and Intel, where they have modified the open source LLMs to run on CPUs with equal performance as that of GPUs, which we use for our hackathon. And we have Jaskaran Singh. He is a person from your city only. So all of us others have come from Bangalore, Pune. So Jaskaran is co-founder of a company called Logic, and they have a tool called Sustainability, which we have used to calculate the carbon footprint, water usage of IT and AI, and we use that in our hackathon also. So the question here is, can AI sustainably be measured as precisely as latency or accuracy? What do you think? Yes, no? So, can we move beyond treating sustainable AI as a marketing checkbox and instead make it engineering discipline? So, sustainable AI with concrete metrics, framework and measurable outcomes. So here our panel brings together the architects and evaluators of BrainMind Sustainable AI Hackathon, whose empirical findings now inform sustainable AI practices globally. So just to give you some example, I have put 2 slides of 2 different use cases which has happened during our hackathon. One is a cancer treatment recommendation within 15 days. Obviously cancer treatment is big. They did it only for the breast cancer, using small model and models from Zero Labs. And you can see the figures there. Later on I might come back to this if you want. And the other one is the RTI search assistant, which is from a company from Gujarat. And this is also running there, where the RTI details, all the documents are put into the system. And anybody, instead of going through the process of filing a request, then somebody, government official will look at it, send it across. It's not like that. Anybody can just look at it, query it and get it. So, my question to you, what percentage of your organization's AI teams track energy consumption as a metric? So anybody where more than 50%, can you put up your hand? More than 50% of your projects track carbon footprint of your AI projects? Okay, 25 to 50%. Okay, I have 1 or 2, nice. We should talk sometime. And less than 25%, but more than 0. Okay, I still have, that's good. So the first question that I go to Jaskaran is about the measurement, because we talked of what we do not measure, we cannot improve, right? So you coined the term energy intensity score and built the Sustain IT to measure it in real time across all hackathon teams. In simple terms, what is EIS and why does measuring energy per unit of useful work matter more than measuring total energy consumption? How did real-time measurement change how teams approach optimization during the hackathon? So here on the screen I have put some dashboard from the hackathon, but just go ahead.
Okay, so EIS, energy density score, it's got a fancy name, but in reality it's not very same formula. But EIS essentially means is that we measure total income, but then we also measure total work. So EIS is total energy divided by total work. In a way, you could say it's very similar to if you guys are acquainted with the concept called unit economics in FinOps, where you do not just measure total cost of the cloud or the data center, you also measure the business outcome of it and you correlate to that. So EIS does that. Now, why is it why it's needed is that we have different use cases in AI. We have NLP, we have classification, we have vision AI. So for all the specific use cases, we have different work done. For some, it might be total number of tokens consumed. Let's say for a chat application, it will be total number of tokens consumed. For a financial application using agentic system, it will be total number of transactions. So at the end of the day, teams were competing not on the metric of total energy, they were competing on the metric of total energy by total work done. So what we saw is that if two teams had a similar use case, let's say for a chatbot, but we discovered that there was 0.6 to 1.2x differential for the same use case, which means even though the use case was the same, even though the total work done was the same, the total energy was vastly different because of the different architectures used. So that was a very good playground for the teams to invite some creativity, get like how to optimize the model, how to optimize the whole architecture. So that's why EIS was introduced, and that's how teams went around that.
Thank you, Jaskar. So we go to Archana. As a hackathon jury member evaluating solutions, how does having concrete sustainability metrics like EIS change the conversation with leadership? Does it shift sustainable AI from nice to have to business imperatives? And given the government's emphasis on AI as an economic multiplier, how can organizations align sustainability metrics with broader business and governance goals? Now, you already know that there are multiple ways of calculating carbon footprint, the whatever metrics we are looking at, flops and so on. Each has its own positive and negative, right? So we have to choose number one, number two, we have to have kind of a multi-level calculations. Just not one single calculation or a number which we have, right? Yes.
Thanks for that. So I would say by taking an example. So let's assume you are flying a hot air balloon, and during hot air balloon you would probably look at the direction of the wind and you would say, okay, is it cloudy, is it not, is it decent weather, and you would kind of start flying. Now the same thing, let's say you are now flying the Airbus or a Boeing, and imagine you are giving instruction to the pilot saying, hey, outside the weather looks cloudy, be careful when you land. Versus giving an instruction to the pilot, this is the wind speed, this is what is the visibility like, this is how much fuel you have in your plane left, and now make a landing, right? So if you are not calculating the metrics of the way you are using AI, it is like telling the pilot the weather is cloudy, please land, which doesn't help at all. So if you are using AI at enterprise scale, if you are using AI to scale and actually get benefits that you are supposed to get, you need to know how much my AI is costing. You need to know how much efficient my AI is. You need to know how much energy my AI is consuming. If you look at the budget 2026, which happened just a few weeks back in February, there was a lot of tax benefits that have been given in our budget for AI, right? So there are a lot of companies tax benefits until 2047. But you have to claim those tax benefits. There's a clause there which says make sure you are giving efficient AI metrics. How do you define those efficient AI metrics? So it's looked at from what we call as the intelligence that you can gain for the rupee that you are spending. Now if you are doing efficient AI, which is also energy efficient, automatically this intelligence will start increasing. Because if you don't do that, you're going to spend a lot more time, energy, money on the energy resources, on your bills, all of that is increasing. So if you are not tracking metrics like EIS in your company, I would say it's going back to my metaphor, it's like telling the pilot land in a cloudy weather without giving any kind of information and benefits. if you have to go, not just get tax benefits, look at how your TCO of your AI implementations are, ROI of your AI implementations are. Any kind of these metrics are crucial, important. And I think the moment you start implementing AI, better start implementing these metrics as well.
Thank you. Very important point. And if you look at the thought process that is here, the 3 sutras. So we are touching on the planet sutra, right? And if you look at the 7 chakras, we are touching the number 5 chakra, which is innovation, resilience and efficiency. And if you don't have resilience, you don't have efficiency also, right? And if you are looking at any startup, if you are looking at any corporate, profitability is important. And where is the cost? The cost with IT is mostly resource cost, compute resource cost. If you can optimize the compute resource, that's where your cost also comes down. Imagine a situation where today a GPU costs, the newer versions, around $60,000 to $70,000. Whereas you are getting a newer version of an Intel Xeon 6th generation chip at around $12,000 to $15,000. See the difference? Where you can get 4 chips, you get 1 GPU chip. Now, PM is talking about AI for all, inclusion of everybody. So if you look at the other chakras where we are talking about the social empowerment, we are talking about everybody's access to AI. Only with GPU it is not going to work. How much ever government wants to give the GPUs. They will give it for only for the trying out part. What about the actual production? It doesn't work that way, right? So we come to the point where we are talking about use of a network of micro data centers, which are green, which are much less costlier, which is much more efficient. And that's where we have founder of Vigyan Labs, Mr. Srinivas Varadarajan. So Sri, the press conference highlighted that sustainable AI isn't just about energy, water usage for data center cooling, and it is not just significant there. So how does edge computing and distributed infrastructure address both energy and water efficiency? What measurements matter beyond just electricity consumption?
Yeah. So one of the things, as if you just look at the AI world, right? There's a training part, there's an inference part. The training is going to be done with just few people. Small number of people. Everybody doesn't need to do training. When you do reinforcement learning, majority is going to be inference. Inference has to be the edge. Inference is a small infrastructure. Just to distribute it, looking at the kind of population density we have hundreds of use cases, right? Hundreds of millions of use cases. We need inference the edge. What does data centers need, right? We need to look at a new form of data center. Just like, the PCs revolutionized the computing, right? Mainframes were there, PCs came and revolutionized computing. We need this inference edge to revolutionize the AI for everybody. Today, as of today, if you look at the traditional model of edge infrastructure, is very expensive, resource consuming. India is a country with, limited scarce land resources, scarce water, power. I don't think they have surplus power. Go to the rural areas, they still have 4-hour, 8-hour power cut. How do you design infrastructure which is energy efficient to the core, consume minimal amount of natural resources, same time eliminate water? So our learnings came from designing Aadhaar and building such infrastructure around the world. We went to small countries in specific nations, 1 million population, 5 million population. There was no need, nor the money to build a very large data center. Then occurred to me that why can't we start building one, show the world that can be done. So what you have built is a micro data center. So what's the definition of micro center? It consumes less than a megawatt of power, or 50 racks roughly. And what we do while building it, we looked at the way data centers are built, because we have been designing and building for decades. Let us reimagine everything. So every component of data center reinvented. So my fundamental approach was, you have a piece of land, how much solar energy can you generate there? So we bought a piece of land, a small piece of land, 6180 to be precise. How much energy can you generate? We can generate only 60 kVA. Can you redesign everything to consume not more than 60 kVA? So we went to the civil engineering, designed the building, reduced the cement by 70%. Also use special thermal material to keep the building naturally cool. Next thing, we redesigned the transformers, eliminated bus bars, We changed the chillers. Our goal was to use zero water for cooling. We use air-cooled chillers. Air-cooled chillers are inherently inefficient. Again, we built our own AML model. When I put our ML model, typically energy consumption of the air-cooled chiller came down almost 80%. We achieved a PA 1.1. That means we applied AI to everything, the server, storage, compute, everything, literally everything. Right? And 1 year today is a data center. We run today. It's about 35 kilowatts of power. Not sure anybody would have heard. 35 kilowatts of power. That's all. We have got 160, 70 devices. Petabytes of data. Organized data is about 2 petabytes. Archival data about 60 petabytes. We run GPUs. CPUs. All our AI level models run on CPU. And I'll tell you just to give you an example. One of our large customers runs a 4B model. Runs about kilowatt of power. That's all. A 4B model with kilowatt of power. And what's the kind of energy you consume per teraflop, right? As a metric is 0.013 watts per teraflop. And so we have reimagined the data center. We can build micro data center. We can build this one in 9-6 months. A small corner plot. You may need grid, you don't need it. Today the battery storage has become very, very affordable. We don't need water. So that's what we are showing the world, that we can build very sustainable, cost-effective, reliable, highly reliable data centers. You will always ask me the question when you are sustainable, green, is it efficient, reliable? What kind of work would you run? We do 9 billion messages a month, next one to UK. A small place. For data center will be expensive. 9 billion messages. We run a lot of workloads. Messaging, we have banks, AI workloads across the globe, right? We have customers already. First set of customers who adopted our technology, they're outside of India first. You know, a customer from Finland was first person to come over to India. So relocate from Finland to Mysore and Bangalore. And then slowly we have customers around the world running out of Mysore data center. Amount of energy we save is phenomenal, right? We save about, with a small data center, we save about 5 million liters of water a year. And our technology runs, banks, financial institutions everywhere, and we have proven that we can build, as a country, we can build millions, thousands of such micro data centers which are energy efficient, sustainable, and it doesn't cost a fortune to build, right? So we offer the same product, we offer the same SLA, service quality, and delivery as Google, Amazon, and hyperscaler. Many of the customers call us the inverse. We are inverse to hyperscaler. A different way of building data centers, demonstrating that we can be sustainable, profitable, at the same time deliver the same product. Thank you.
Thanks. So, I don't know if you've heard, he talked about a 1.1 PU. Generally, big data centers, a very good one is around 1.2. Most of it is 1.5 and above. So you can see the efficiency, power usage efficiency. And another thing that he talked about is the size. Today's big data centers, we are talking about hundreds of acres. So with that hundreds of acres, per acre, what is the amount of work that is getting done is something which we have to start measuring. So now that we have learned about measuring, now we will talk about optimizing, right? In the hackathon, we talked about a 4-layered architecture where layer 1 is design and data. So right sizing models, efficient data handling. Layer 2 is the training and tuning using things like LoRa, quantization, efficient fine tuning. Layer 3 is inferencing and serving, which is like using RAG, using caching, using prompt optimization. And 4th layer is infrastructure, which is edge computing and efficient hardware selection. So with that, we will come to Vineet. Perhaps the most surprising hackathon finding was the layer 3 optimization, which is RAG, semantic caching and prompt engineering, reducing energy consumption by 60 to 80% before teams made any infrastructure change. Can you explain why these software level architecture patterns deliver such massive gains? What should the development teams prioritize? Is it model optimization, architectural pattern, or infrastructure upgrades?
Hello. So I'm Vineet Mittal. I'm from a company called Zero Lab. You can look at the website www.zirox.com. So the reason we are having, first of all, the sustainability discussion is because GPU is very power hungry. A single GPU consumes the same wattage that your geyser consumes at home, 1 kilowatt per hour. Now, when something consumes 1 kilowatt per hour, we all should be really alarmed, right? You know, and many of these US data centers, they are coming to India because they run out of power. The question for us in India is that are we just going to sell our power that was meant for residential use and give it to these large American data centers for even more, what we call as bad air, in my view. So we started questioning some of these things, and as Srini already mentioned, one major advancement that Srini and his team has done is to create these micro data centers, which you all heard of. The second point I will make is what Zero Labs is doing, which is to make AI available on CPU. Okay? Now, you all have been hearing that AI only runs on GPU. That is not true at all. The main thing that AI needs is ability to calculate two matrices. And CPU, Intel's 5th generation, 6th generation are very well equipped to actually calculate matrices at clock speed. I can multiply 2.3 billion matrices in 1 second. And then we can have more code. So now, suppose we can do AI on CPU, what is the real benefit? That is the first point. The real benefit is that your cost will reduce 1/3 in terms of power. From 1 kilowatt, you will go down to 250 watts. Right? That is a very, very clear one. The second point is that your cost, the initial capital investment, one GPU costs about 20 lakhs, server grade GPU. Intel GPU will cost about, let's say about 3 to 4 lakhs. So the cost infrastructure also is massively fixed. Now, to address the Miladji's question, which is, what we saw at the hackathon. What we saw at the hackathon is that when you are building AI applications, you have to be very cognizant of your data pipelines. You have to carefully engineer them so that you are not creating too many long contexts. And what you can take from the cache, why ask LLM all the time the same silly question? Right? So there are various middleware techniques that the participants were able to use. They were able to use small models as effectively as the large models, and they were able to run it on CPU. So I highly encourage all of you to look at our website. It's a game changer. We don't really need NVIDIA chips in this country.
Thank you. I think now we will go to we have looked at the infrastructure, but software is also important. So Ashwini Vaishnav talks about the application layer, right? And that's where I'm going to Naresh. So from an enterprise perspective, what would it take to integrate energy efficiency metrics like EIS into the standard dashboards that your AI platform teams already monitor for latency and accuracy? What resistance do you anticipate from engineering teams, and how would you address it? And you have been working with the DevOps, SRE kind of area, the observability kind of area. So how does the sustainability related observability also play a part here?
Thanks, Niladji. And I'm building on what my colleagues on the panel have said before. Purely from an enterprise lens, the idea is to sort of look at it in the same operating rhythm. All enterprises, right, big, small, large, have some sort of these engineering metrics that get tracked. Right? All engineering teams track them. Very likely you are tracking now for accuracy, for throughput, and things like that, right? So if you can sort of bring in some of the EIS related metrics that we spoke about earlier, sort of into the same operating rhythm, I think that's first. Second important thing I would say is the ability to instrument this. Now, you perhaps need to build hooks into your containers, into the hardware, right? And again, GPUs, CPUs, whatever you eventually end up using. Once you build those hooks, you have some of this data actually coming out, right? And once that data comes out, the ability to actually look at this data in a single pane of glass. So you're looking at your engineering metrics, you're looking at these efficiency metrics together. The second aspect is sort of thinking about this from a cultural unlock perspective, because a lot of times engineers sort of focus so much more on the other aspect, right? The throughput and the velocity and those kinds of things. So helping them to sort of see some of these metrics, and these metrics look a little different, right? So you may be looking at what does it cost or how much energy am I expending every time I inference, right? Every time I go back and forth with the model, small language or large language models, right? How many joules per inferencing, for instance, right? So if you start looking at some of these metrics and then bringing them in line with your other engineering metrics that you are actually already tracking, you can in some ways drive the cultural unlock where all engineers, engineering teams, leadership, operations team, all of them start to look at it in a single pane and sort of think of this. The other thing we are constantly doing is driving this balance, right? So if I were to optimize, if I were to actually change my performance parameters and move the needle on performance, how much do I, sort of from a benchmark perspective, go and look at other aspects of the model, right? Or other aspects of the hardware that I'm consuming. So how do you draw this balance? And once your metrics are in place, you have the ability to actually benchmark. So I would say, one, bringing these on the single pane of glass. Second, ensuring that these benchmarks are actually used in decision making. For example, I would not let a model get into production beyond my development and testing if it doesn't follow some of these EIS benchmarks. Right? So I think, Neeladi, that's what I would say sort of helps in terms of enterprises looking at this at scale.
Thank you. I think every developer also needs to start thinking of sustainable activity along with whatever else they are thinking today. Then only things will change. It will not come as a fit it later on. Right? Now coming to the layer 1, Jaskaran, which is the design and data. Now we saw in the hackathon that 7 billion parameter models with LoRa fine-tuning matched 70 billion general purpose models at just 10% of the energy consumption. There was 1% decrease in the accuracy. This directly supports the economic survey's position against the very resource-intensive approach the West has followed. Can you explain the right sizing principle? How does task-specific specialization beat the encyclopedia approach?
Sure. So, before coming to the right sizing principle, I think this question is a proper personification of the saying that we have jack of all trades is a master of none, and so that applies to large language models also, by the way. So, I think an hour ago I was having a conversation with Vinny from Zero Lab, and we were discussing how, let's say for a homegrown project, if you're using an LLM of 80 billion parameters, that's essentially you have data and knowledge of the whole British library. Do you even need that knowledge at a time? Or do you just need a couple of books for a particular use case? That's exactly what right sizing is. So right sizing can be divided into two parts, qualitative and quantitative. So qualitative comes first and is also the most important part of the right sizing. In qualitative, you choose exactly what type of models do you need for your use case. If it's a chatbot, do not by default jump to, let's say, Llama 70 billion. Try 7 billion, try 3 billion distillation. You have better data available for training. So, and quantitative is, if you got the data, if you got the model, now you try to right size it architecturally, technically. You try to optimize the instances on which it is run. You try to optimize the data. That's the quantitative part. And what we saw at the hackathon was there was 50 to 80% of energy reduction once the team did the qualitative and quantitative assessment and approach their use case accordingly. Yeah, that's about it. And another point, for enterprises also, for most of the use case, there are around 70% repetitive queries. So essentially for all the enterprises, you do not need large language models, you need smarter, small language models. That would reduce cost as well as data.
Thanks. It's an important point that even Google said that the searches that happens in Google, I'm talking about the normal searches, 80% of the searches are repetitive. It's not something new. So when you are sending queries and you are making the LLM to work for you, you don't need it to work. Right? You can always keep something in a separate LLM, go through it which is already there. You don't have to do the entire processing again to find things. Right? So back to Naresh, on the training and tuning, where profiling is critical, the hackathon showed teams who systematically profiled their training and inference pipelines achieved 2 to 3 times better improvements than those who didn't. With Budget 2026 supporting 80 India AI labs and 10,000 technology fellowships, how can we institutionalize profiling as a standard practice? What does this mean for AI engineering education?
So thanks, Neelabri, again. So, individually, I feel profiling, right, has to be seen as a base engineering discipline. So just the way we train folks on tuning, training models, working with models, profiling also has to be sort of falling into that same skill area. And more importantly, it should also be something that we teach people ahead of, sort of getting into some of the advanced techniques, right? So that is one. And what I've seen, right, within the enterprise, working with customers, that a lot of times we sort of go and tend to point fingers at the hardware and things like that, right? But a lot of times when you actually go deeper, you will find that sometimes there are misconfigurations. Sometimes the data pipelines aren't designed the right way. The workflows aren't as efficient, right? So there are other problems than just pointing fingers at the hardware and things like that. There are a lot of things above that layer which actually are sort of suboptimal in a way. And profiling is perhaps the best way to actually identify many of these, I would say, ahead of time. Second, if you actually go to the design time, you can simulate a lot of these, right, and then sort of look at this in that sense. Now, from a skill perspective, the ability to actually read, through the traces, understand and analyze the traces, look at these graphs that actually come through, right? I think those are skills that we need to develop alongside, all the other things which are perhaps more glamorous in nature. You touched upon the budget part also, right? So look, I mean, from my perspective, I think this is a huge unlock in terms of allowing people access to environments that usually, people would not have access to, these labs. And then the 10,000 plus technologies that you spoke about, I think that's a great way of enabling massive scale capability building across the country. And again, from the skill perspective, I would say look at profiling as one of these base engineering disciplines alongside all the other things from an AI perspective. So that people can actually look at this right through the value stream, which means you're looking at artifacts about profiling as part of your architecture and design decision making. You're looking at these as part of the gating criteria. You're looking at this as something that will make decisions and approvals based on, right? So and once it is embedded as part of the value stream, you embed it as part of your standard gating criteria. You will notice that you are essentially not looking at optimization at a later point in time, right, when things have actually gone wrong, but you're looking at optimization, you're looking at driving value right through the value stream, through and through. So the massive shift left can happen because of this. And I am very hopeful that the announcements that have come in the budget, whether it is these labs, 80 plus labs, the 10,000 plus technology related interventions, I think those are going to be a big help in sort of driving this capability.
Thank you. And that's what we are trying to do also in our Sustainable AI Center of Excellence, partnering with all of them. So Archana, coming to the layer related to the governance and framework, so from your experience advising organizations and evaluating the hackathon solutions, how should companies integrate sustainability criteria into their AI development lifecycle using this framework? What practical checkpoints should be built in at each layer from design through infrastructure? And how does this align with the summit's focus on safe, trusted and inclusive AI?
So, this is what I would say, right? Nowadays, there are a lot of job titles that are floating around which is called an AI architect. And if you go deeper and actually look at what those guys say, it's probably at a very cursory level. In my mind, when enterprises look at truly bringing AI into their ecosystem, the whole ecosystem architecture of AI needs to span across 4 layers. The first, and some of our panelists have referred to it, the first one, where it's about the design and data, which means are you truly using the data that's needed Or do you have all the junk data which may not be even needed under the sun, which is used for your training, fine tuning, all of that? And if you just make the data whatever is truly needed, you not just make it more sustainable, you also reduce the risk of hallucinations. You also reduce the storage requirements. So all of that is there. So I would urge that for layer 1, the enterprises should actually start looking and tracking their data metrics diligently in terms of what they are doing. Things like how much is the mileage of data. So just to put things in perspective, which means that how much is your data traveling to get that inference out. So some of these things is what enterprises need to start looking at. If I look at the layer 2 of architecting that AI system, which is about the model, and Dr. has referred to say that, hey, what are the kind of models that I'm using? I don't really need large-scale LLMs for every single query that I'm running. A small one is good enough for me. I don't need to boil the ocean just for a query of 2 plus 2 equal to 4. Not needed. So think twice what models you are selecting. Do you really need that becomes crucial. Also, let's say if you are in the business of training models yourself or fine-tuning models yourself, for every 1% accuracy that you are inching towards, you might start seeing that the performance is getting degraded and the energy requirements start exponentially increasing. So these are the kind of parameters that you need to start putting it at layer 2. If I look at the layer 3 of the architecture, which is more about thinking of how your complete inferencing is happening on a day-to-day basis. Because training and all may happen once in a blue moon, or probably at some periodic intervals. But you are using those apps, you are inferencing them on a day-to-day basis. You are putting those queries. So things like caching, looking at do you really need to make sure this query goes to the LLM, what kind of caches you are using, what kind of optimal solutions, how you are architecting that becomes crucial. And then comes the layer 4, which is your hardware, which is to say that I don't need GPUs for everything. I can have a combination of GPU and CPU. I can have some other edge AI solutions which are also coming into play. So if you incorporate your architecture in all these 4 layers and put metrics at each of these 4 layers, that's where I would say that your enterprise is truly looking at sustainable AI, efficient AI, and also AI which is giving you true ROI and not just wasting money.
Thank you. A quick question to Srini. One of the things that we see is that when we talk about GPUs, we are talking about so much of performance. But the point is 60 to 70% of the GPU time is idle. The reason is because the data is not residing on the GPU. The data is residing somewhere else. And the latency of the network is not good enough to handle what GPU can process. So why have GPU? So from this point of this GPU starvation problem, and this becomes more complicated when it becomes a RAG architecture that constantly retrieve context from the knowledge bases. So how does micro data centers address this bottleneck? By co-locating compute with data. And given the hackathon's findings that contextualized small models with RAG can match large models at a fraction of the energy cost, how does edge infrastructure make this architecture not just feasible but optimal?
Yeah. I think one of the things in what's happened historically with AI, OpenAI pioneered AI. People started using OpenAI APIs, but their data resides nowhere, on-prem or on AWS or Google. People build applications which are going across package right? And that's where it's evolved, and slowly nobody bothered about GPU really. It made sense for the people to sell more GPUs. Look at today, directly inferencing. There's not a network way. The GPU operation is actually amazing speed. You have thousands of cores operating. Are you able to feed data at the same speed? And there are multiple parameters, right, which affects the GPU. One is your bus. Historically, all our GPUs always playing over so many GPUs. They are running PCI 4. They have very limited capacity bandwidth. DDR4 memory. Network is legacy network. Legacy network. You have 10 GPUs, 1 GPUs. So today, large amount of inference. I don't think people measure GPU inference as necessary. When it's a good network, getting more than 30% is very hard. You simply adding more and more GPUs. relook at the entire application. Some of the workloads are stateful, some of the workloads stateless. And you need to keep data closer to the GPUs, right? And of course, you can keep in your VRAM. VRAM is limited, expensive. Can you keep in your local RAM, local NVMe drives? And again, you need to fetch data from the storage. Traditional storage is not good enough. So you're looking at latencies of milliseconds. You need to get out the micro data. So people need to design data centers. So you need to both north-south traffic and east-west traffic. And east-west traffic has to be hundreds of gigabytes. It's no longer a 1 GB network, 10 GB network. You need to look at your network for load latency because we have many kinds of technology available today. NVIDIA has NVLink, there are alternatives to NVLink, there is RCOM, in-memory, you can do a remote RDMA across servers. You need a high-speed backbone. You need to design a network to be able to handle the GPU, right from the motherboard to the bus, to the memory, to the storage part, right? Every component, relook at it. Otherwise you end up GPU starvation. What we figured out today, I said, we look at some of the boxes available in the market, are not even good enough. People are putting high-end 800s. If you say 4 pass, not good enough. So today, we don't need 800s. High-speed PCI buses, PCI-5 and beyond, build our own switches, and we do RDMA and high-speed backbone. We're able to implement it much higher performance, very low latency, much higher. And this is critical because running at less than 30% utilization is a colossal waste of money and resources, right? And I think as all of you are running inference or training, start measuring GPU utilization before you ask for more GPUs. What's the bottleneck? Very often data is a bottleneck. GPU is waiting for data from somewhere else. Data in the low storage, data in the sans disk, SATA disk, or a model. Even the model waits, you store the model on a low-end disk. When the request comes in inference, it takes, I have seen many times, it takes seconds to load the model. It is 0% utilized. So you need to look at the whole life cycle of the inference and keep data closer to the GPU. And later probably when we shift over the zero apps, the CPU one after again, you need to keep the data close to the CPU. You can't put a lower device, right? People need to understand this bit of engineering. It is not about writing some piece of Python code, understanding a little more in engineering. How does the compute, how does the GPU work, where the data residing? I see that is a big problem, and I think we need more insights, metrics, people to measure the utilization of your AI infrastructure rather than asking for more and more, right? And that's the way forward. The country is starved of resources. Why can't you utilize better, right? And I think we talked about metrics. I think more and more developers look at the peak utilization about metrics, IO latency, weights, IO weights, it's happening. Identify the bottleneck and relook at your infrastructure or look at the data. Can't change the infrastructure, bring data closer to the GPU. That's one quickly. Many of the customers I told we are running on the PCI 4 bus, the GPU plan. It sucks. You're loading the model from the server, the storage is 10 GPS, 100 GB model, huge. Take seconds for the inference request comes in, take seconds for the set. Why don't you put a RAM disk? Nobody is cheaper. Put in a RAM disk and load the model instantly so that you got into IO. I think there are interesting engineering solutions to overcome this GPU weights and include this. Thank you.
Thank you. Even one interesting point is that today's API structure with the agentic AI coming in might not be very suitable because we are talking about stateless scenarios, whereas in agentic AI we are talking about stateful scenarios. Right? So that also needs to be relooked. Now coming to Naresh, quick question on, so Budget 2026 proposes a committee to assess AI impact on services and jobs. How can large organizations like Infosys balance optimizing existing AI systems for sustainability while preparing the workforce for this transition? What hackathon techniques scale well and which face challenges at enterprise scale?
I'll sort of keep it short. So, what we saw in the hackathon was, sort of small use cases, impactful but small, right? And enterprises, obviously, the scale, complexity is of a much different order, much higher, right? So essentially, we will have to take some of those learnings back into the enterprise, any organization, any size, right? So first and foremost, do you have the inventory of all your AI workloads, right? And you will find that there's so much work happening in enterprises, right? Sometimes you don't know everything in every pocket, every place in the enterprise. So do you have the complete inventory? The second clear aspect is, do you have baseline, right? We spoke about metrics, we spoke about these measurements. Do you have the baselines for how these workloads are performing and across element? You may be running some workloads within, you may be working with some external partners, hyperscalers, etc., right? So do you have baselines in terms of cost, energy, etc., for these different workloads? The third important thing is, do you know which workloads are less expensive, more expensive, less performant, more performant, right? And typically, I mean, the 80-20 works everywhere, right? So you will find that 20% of your workloads or 15% of your workloads are actually the ones which are, sucking out a lot, right, out of efficiency, cost, and so on. So once you have identified those, then sort of, the measurement in some ways creates a baseline for you, which can align your leadership, your engineering teams, your operations teams, and everybody is on the same page in some sense. The second thing is the ability to actually separate out in the interim where your BAU operations, right, business as usual operations run, and where your innovation experimentation happens, right, sort of a lab or a COE. And at some point you take stuff from the COE and put it into the mainstream. So how effectively do you do this, right, on an ongoing, consistent basis? Third element is with respect to techniques, right? Now for enterprises, we spoke about RAG, very useful, right? You can actually bring down a lot of the cost using RAG. Right? Second element is caching, reusability. Again, works very well with the way enterprises typically design systems, applications. Nilad referred to APIs, right? Microservices. These are concepts that work fairly well, right? You can actually reuse. You don't have to reinvent the wheel. You can optimize in a substantial way. The third element is prompts. And I think Archana touched upon this, right? I mean, the mileage. How many back and forth transactions do you have to do to get to a certain output, right? You can substantially reduce that by better prompt engineering and designing your prompts and systems a lot better. So I would say, I think from an enterprise standpoint, these are some of the things that you need to sort of focus on and drive some of these things.
Thank you. So now that we have seen on the corporate side and all, now let us go to the academia, because without academia, this is not going to scale up to the extent that we do. So Dr. Gayatri, the Green Mind Hackathon exemplified community-driven innovation and broader summit, that is this summit, has pioneered a Jan Bhagidari approach with 550 events across 115 cities, engaging 300,000 plus participants. So this grassroots model is very different from elite tech conferences. How can we sustain this momentum? What role should academic institutions play in ensuring AI development remains inclusive and accessible, especially as we scale the hackathon's learnings nationwide? And along with that, I would also like to ask that the budget also creates a massive AI education infrastructure. And how can we ensure that Green AI Playbook and hackathon learnings are built into AI education from the ground up? What should the Sustainable AI Center of Excellence, which is in your location, prioritize to shape these labs? And should EIS become a standard as a curacy in AI courses?
Thank you so much. Thank you first of all for having me here. I come as an aggregator of all this, intelligence which is sitting in me. So we have started a Center of Excellence in Sustainable AI at Sir M.V. School of Architecture in Bangalore. So the whole idea where we started when Karan and all were talking about running LLM for a training model, which consumes almost equivalent to 7 lakh liters of water. So that's something which can be supplied for a small neighborhood. So this is the awareness what everybody should have, when the students are coming. So with the surge in engineering students, where this AI is becoming the foundation branch, where 16% raise has happened in the last few years. Right? So this is something which we as academicians have to really take into consideration with what we started with Center of Excellence with. Now coming to the resource inclusivity is one of the main objectives that we are focusing on, as we see the GPU requirement for AI models. So what we are encouraging our
interns or our students to kind of use the CPU-based, the compact AI. And so the three ways we are looking resource inclusivity is in three ways, like with technology agencies where we kind of use this compact AI and taking help of Zero Labs. So these are also like kind of using them and bringing out the models is what we are looking at. And second is the localized intelligence. So the AI coach, like we are saying, it has brought in 7,000 plus data sets. So can we use these local, to solve local problems, can we use these local solutions than depending on the global models? The third thing which we wanted, academic stewardship. So that's where we are looking at where we can kind of have the students working on the local problems is what we are looking at.
Thank you. So, before we open it for the questions, one point that
Just generally want to say that there are opportunities in AI at all the layers that we discussed. See, to make a good data center, you need mechanical engineering skills, you need civil engineering skills. To solve the problem that we are solving at Zero Labs, I have 10 PhDs in mathematics and 10 very good system engineers who can code at the assembly level. For writing applications, and India is a country for writing applications, we still need a lot of good engineers to invent more middleware and data pipelining techniques. That will actually help you write AI applications in a better way. Writing good AI applications is not easy. So I encourage all of you to look at our websites and please stay in touch. We can clarify more of your doubts.
thank you. So now we will open it to any questions that you have here. Yes.
Clarify one thing to everybody, and Srinivas made the point earlier. That way GPU is sitting inside the architecture today is through a PCI card. And even GPU card does not have access to more than 40 or 80 GB of RAM. So when GPU itself wants to load large models, it needs a higher degree of bandwidth between the GPU. And that causes another $1 million of technology that you have to throw at the problem. So the point that we all have been arguing is that don't think like hyperscalers. Hyperscalers are not here for our benefit in India. They are thinking about their countries, their scale. It's a different problem they are solving. Right? In India we worry more about jugaad. Right? अगर एक CPU से काम चलता है तो तलवार में. That is the point. जरूरत क्या है अपने बड़े डेटा सेंटर की? अगर एक छोटे रूम में 2 सर्वर डाल के बैठ सकते. And his work in the micro data center is really inspiring. You all should visit Vigyan Lab and see what they have done. Right? And I can give all my models for free just for you guys to become familiar with it. But when you get to the core of the problems, then you will realize that hyperscalers are sometimes over-engineered. And maybe they are solving something else and we are not the right country for that.
Okay. See, thanks to Anusandhan Research Foundation, we are building a large number of micro data centers in the country. So we'll just in the next quarter we'll have the IITs, NITs, paper ITs, and a couple of education institutions having. So work is on right now. There's a construction phase. Next quarter that the government has recognized the need for micro data in the country. So we'll have a model data center, one IIT, one NIT, one paper IT. A couple of institutions, 5 education institutions have been chosen. Maybe next couple of months we'll make an announcement. And my mission is that can we create 10,000 such micro data centers in the country, so every student, every academician, every startup has access to affordable AI infrastructure.
Thank you. You had a question.
I think the question is what methodology you adopt to restrict the code, right? I think we look at the fundamental aspect of energy wastage